Hello everyone, good morning and welcome to this webinar, and also welcome to our brand new recording studio here at Man & Machine. So good to see so many people on this webinar, and thank you again for joining us on our social media if you're following us later. So this webinar, we're going to be looking at a really exciting topic, one of my favorite topics of all, the topic of design automation. So the idea of being able to automate your internal manufacturing processes and to be able to do things as efficiently as possible is something that really is close to my heart and something that I'm very passionate about personally, making sure that our customers are as efficient as they possibly can be, making sure that all their processes are up to scratch. We're just fiddling around with the camera a little bit. We're still working on the teething issues here. But joining me this morning is Chris England, our technical consultant that's been involved in many of our projects with our customers, helping them to automate their processes. So good morning and welcome. Of course, this is we're recording this, so if you're watching this on YouTube, hopefully you all know our social media channels. You all know where to follow us on LinkedIn, on Facebook, on Twitter, on all the social media. So please like and share and follow our channels. We really appreciate your feedback. And then any previous webinars or events that we host are all available on our channel. So please go ahead and follow us after this webinar this morning. So welcome, good morning. So my name is Simon Brand. I'm the manufacturing sales manager here at Man & Machine, and my contact details on the screen. Now, I've been involved in the industry, in the manufacturing industry, for longer than I like to remember. My personal passion has always been to help customers with their actual workflow processes, whether that's from sales to design, whether that's from design to manufacturing, or the entire process. And being able to be as efficient as possible whilst they're doing it is something that really gets me up in the morning. Now, when we think about design automation, of course, many of us, the first thing that comes into our minds is the old, online car configurator when you're speccing up your favorite color car. Whether you actually can afford it or not is another question, but I've done that many, many times. But here at Man & Machine, we think about automation in several different ways. And what we do is we look at different levels and different products and services of ways that we can help our customers to effectively achieve their personal goals. Now, this might be a variety of different softwares, whether we're talking about internal configuration, which is kind of the main topic of conversation today, the one that most of us are interested in. The one that you're talking about, I'm designing a product repetitively over and over and over again that's same but different. A longer one, a fatter one, a shorter one, a taller one, whatever it may be. And there may be rules that define, whether there's more holes or whether there's different design parameters that are changed based upon the selection of the user. So if you are in a design environment and you're repetitively, constantly opening up the old one you did, but then maybe just tweaking it, well, why not think about automating that design process so that instead of that 1 hour, 2 hour design process, why not open a template, change a couple of parameters, and then the software drives it for you based upon the rules and the code that are set in that template. Of course, what a lot of customers are thinking about now is how you can take that to the next level. So once you've got your design processes up to scratch, why not then think about pushing that a little bit further, perhaps to your sales team that are out on the road, demoing it to the customers, or perhaps, to the clients. Obviously, that depends on the products that you're selling, whether you want clients to be able to design their own products or not, or whether you prefer your salespeople to be able to do it, or your project managers. And that's something that a lot of our customers now are thinking about in using Autodesk platform services. Mundane tasks, something that I know causes designers a lot of pain, searching for information or repetitively always creating DXFs or PDFs at the end of a job. Or we always have to, when we release a product, we always have to create step files, DXF, BIM models, whatever it may be, PDFs. And the ability to automate those tasks, trigger those events when certain things happen, is something that can save a lot of time and energy of the designer. The designer that has more things to be concentrating on, like the design of the products, rather than how many products, how many different file tapes they have to create at the end of a job. So there's a lot of things around the term automation. And I just kind of wanted to lay that out there at the start of this presentation, because automation does mean a lot of different things to a lot of different people, but this is kind of how we sort of think about it and some of the technology around what we're thinking about. Now, Chris is mainly going to be focusing on the sort of traditional Inventor-based iLogic configuration. I did want to just quickly show you where you can get to, or give you a couple of quick examples. Now, we've got a client that designs toilet cubicles, pretty high-end toilet cubicles, and of course they're receiving layout or space planning ideas from their clients, and they are having to lay out the cubicles in a certain way. Now, there may be rules around the size of these cubicles, there may be rules around the size of the disabled toilet, whatever it may be. I'm not familiar with the actual rules of designing toilets, but of course, to do that, or to design a product like this, you'd have to then, traditionally, obviously draw the walls in Inventor and draw all the pieces, and then eventually get to the point where you've got a bill of materials that you can actually go and make the stuff. Now, one of the things we worked on with this client was the ability to automatically design and drop in these cubicles as they see fit, based upon the rules. Now, there are a lot of I appreciate there may be customers on the, you may have a lot of knowledge and experience in your team, but perhaps some of those are getting to the point where you need to hand some of those knowledge and experience down to the newer designers coming out of university. Well, why do that? Why not just ask the system to do that, so that any old monkey can, no offense, Chris, you're not a monkey, but any old monkey can come in, enter a few parameters, and away you go. Now, that's when you start thinking about, when I think about monkeys, Chris, I'm not thinking about designers, I'm thinking maybe about the salespeople that don't know what they're doing, don't know the rules behind it, don't know what's manufacturable, but actually they just want to be able to click a few buttons, enter a few parameters based upon the customer feedback, and the design is done, the bill of materials is done in the back end. So a really exciting project that's actually revolutionized the way they do it. It's taken a design process from, I think it's 3 weeks, down to a matter of hours at the most. So a really phenomenal thing. Now, of course, if you're talking about a 3-week design process, that's great. But then what happens when the customer changes their mind? What happens when the architect moves a wall? Of course, you've got to do another 3-week process. Well, not anymore. You simply enter a few more parameters and away you go. The thing's done again. So revolutionary for this customer, and something we're very proud of. And I know they're leading the way in that industry. Of course, that's more of a layout sort of example. The other example is if you're involved in product design, designing a physical thing that may have rules and variations around it. And I know Chris is going to show you some examples of the sort of stuff that we've done in the past. This example is a customer that's designing wind posts. So these are pieces of steel inside of a building, holding bricks and holding mortar all together. I may not be using the right technical terms there, so please don't shout at me on that. But of course, they're very configurable. The length, the size, the width, the diameter, the length of the fixings, the number of holes, and there are always rules around what defines where the holes are, what the spacing of the holes, how long, and of course what traditionally you would do if you're using a 3D modeling platform is to open up the old design. Oh, I did one of those 6 months ago for a similar client. I'll go and open that, copy design and change it and tweak it as I see fit. But of course, there are rules around this. So who's to say that designer that's doing that knows all the rules, is capable of being able to design that to the right specification with the right holes and the right parameters? Well, not anymore. The software knows the rules are baked into the product, and nobody can get it wrong. You're simply entering in a splash screen a few parameters, excuse me, a few parameters that drive the size, the length, the holes, the width, whatever the configuration is, and that designs the product from scratch. Wonderful example and we've done several of these for different clients, and they're changing the way that they're able to design. Now, of course, a lot of this of what I'm talking about is our internal based Inventor configurators. But I also wanted to give you a flavor, an example of the next level. So a lot of clients at the moment are thinking about how can we host this on a website. The internet has come a long way since it came about, and we're now in a position where internet speeds are able to process this technology and push configuration to the next level, whether that's salespeople out on the road working with the clients, or whether that is the actual customers. So this is an example. I'll be honest, this was a video I recorded yesterday. I didn't want to do this live, so I'll just click and I'll talk over the top. But this is online using a web browser. Now, this could be any web browser. It could be on my mobile device. It could be, I actually did this on my laptop upstairs. But I have a set of projects, and you saw there a wheel project and a tool project. And all the configurations are built in. Now, the first thing to note is this is using the internet as a viewing platform. I'm able to do all sorts of things like an automatic exploded view. I can measure, I can mark up, I can section plane, I can zoom in, I can zoom around, I can pan as I see fit. Now, if I'm a salesperson out on the road trying to sell this product to my clients, a picture paints 1,000 words, as they say. The ability for me to sit with my client and show them what their actual configuration is going to look like gives them the confidence to place the order, but it also gives me as the salesperson the confidence that we can actually deliver the product as we see fit, because I can't mess it up. The rules are baked into the software, they're baked into the cloud then, and the selections are, I can't, it's only going to give me the options that are available. So you can see here, I'm going to change a few things. I'm changing some of the spokes and the size and the whatever it may be, my options. It's also giving me a price. So this might be a customer-facing configurator, and you want the ability to upfront give the customer a price. And obviously the price is dictated by some of the parameters that I've chosen, some of the sizes, some of the diameters, whatever it may be. And then it gives me the option then to see what my actual product looks like. Again, I can section, I can exploded view, I can do all that sort of stuff. I think I did actually show the measure tool. I think I forgot originally when I was doing this, but the measure tool, being able to take diameters, take points and measure as I see fit. Of course, taking it a little bit further, because the software knows, it already has a bill of materials built into the software. I already have, if you've, I don't think I've set it up, but you have the ability to download 3D models, or that could be BIM data, or it could be a drawing or a DXF, whatever I've set up in the cloud platform. So a really useful technology if you're thinking about how can we beat the competition, get things either for our salespeople out on the road that don't necessarily want to have VPNs onto the server and all that sort of stuff. Get it on the cloud, give the ability for the salespeople out on the road just with an internet connection, wherever they're sitting in the world, to be able to configure the products and not mess it up. So that's a great example, and we're seeing a lot of clients now pushing it to the next level. Now, I'll skip on to the next slide. So without further ado, I'm going to sort of wrap up and hand over to Chris now, who's going to walk you through a good example of how he can build a configurator to share the configurator using Inventor iLogic and take it to the next level. So Chris?
Thank you, Simon. Is my screen sharing? Am I sharing the right screen? Did it work?
Your screen now. Yes, we got your screen, Chris. Thank you.
The Inventor one. Inventor,
yes.
All right, good. Doesn't have the box around that Teams normally has. So I had a moment of panic. Right, thank you. So as Simon said, I'm going to be showing a baseline configurator and discussing through some of the points that we look into with our clients. So in this case, it's just a local configurator. I like to use a basic part that's just empty to start the population of my files. So just to show you what's happening in the background, I'll get to my working folder quickly. It's just on my desktop. So in my working folder, I've got a configurator part, which is the part I now have open, and I've got a jobs folder here where I've got a bunch of test jobs that I've made. So what I'll do here, and my form has already popped up on the wrong screen, So I can type in a project name and a job number. In this case, it's just going to make 2 folders, a folder and then a subfolder. So I'll say webinar and I'll just do MA. Right, and when I say create, so if we watch this folder here, it's obviously not there yet. And we'll bring it back. We'll see that the webinar folder's now appeared, and we have a man machine folder, and we now have all the files we need for our configurator. Now, in this case, I have a fish tank with a fish tank stand and a bit of a cabinet below. And it's just got some general parametric sort of iLogic rules. There's a couple suppressions involved and a few other things, so we'll go through it. So let's size our fish tank. So it all starts with the fish tank size. As might need a custom size. So let's do a width of 1.2. We'll do a height of 550 and a depth of 500. And I'll hit apply on that. And my tank will size and my cabinet will size accordingly. And then when I go to my actual cupboard size here, I can then choose the height of my cupboard. So let's bring it down to 1 meter. And I'll start with that just to show. And then when it comes to the panel thickness, I don't have a good example to show on the actual panel thickness. Let's look at this bottom panel here. I could go potentially down. Let me see, it just drops a little bit. It's not easy to see there, but I'll do it on the door thickness as well. If I go to 18, we can then change the door thickness. All the other panels are then adapting to align. And of course, that's just general parametrics when it comes to Inventor modeling. So that's something you can do even without iLogic for the most part. From driving it from an assembly level does need some rules. But when it comes to something a bit fancier, I've got a couple rules built into my doors here. So I can build some semicircle cuts in the glass, or potentially just go for a straight plain board door. I'll put it back to the rectangle for now because then we can see what's going on the inside. And then I've just got the number of doors as an option here too. So I can go to 2 doors, which just evens it out, puts the shelf on the left because I always wanted one of my cabinets to have a shelf. You can see my little filter in the bottom on the right, which is why we wouldn't have a shelf there. Suppose there might be need for customization if a customer wanted to build a sump into their fish tank or something like that. Oh, excuse me, I just apologies, I am a little bit sick at the moment. So then I got my lid size options. Once again, just some simple parametrics. So if I go and change my lid height to 110, and then I can also change the overhang, which changes the amount that the lid overlaps the tank. So let's put that down to 30, and we should see our lid lift up a little bit with all the interior bits staying at the level of the fish tank height. So that's all really, I suppose, quite simple parametric modeling, apart from, I suppose, the suppression on our doors and the rules to change dividers and move dividers and all of that. And of course, from here, if this was our fish tank done, if it was just a preliminary design and we're trying to send it out for quote, we would then have the ability to go and create a BOM. Now, in this case, I've not gone for any custom type BOM. I've just made a simple BOM rule. When I hit OK there, like so, has an error message, but that's okay. I've got a basic BOM. So this already is a very neat, but it's got a cutting list. And what you'll also notice is based on more messages, based on the fact that I've got some 3D annotations, my thumbnails actually come out with those 3D annotations, which is quite cool. I don't know if any of you knew, and that's just base BOM functionality from Inventor, really. But I've also mapped out key parameters there to give me a bit of a cutting list. So I've got all my cutting sizes ready to go. And I've had to add in a height as well, because some of them I used a height parameter instead of just length and width. Nonetheless, there's my BOM. I also have, ability to create things like DXFs as outputs, which will just make a DXFs folder. That rule I actually didn't tweak from a sheet metal, so because there's no sheet metal components, but we could do it on a front face extraction or something like that. And then what you also notice is, my cabinet has mismatching sort of materials at this stage, or appearances. I guess it's always misleading to say materials when you're just looking at appearances. But nonetheless, I thought it would be a good idea to start looking into a rule and how we could potentially have all of those materials aligned. So what I've got here is I've got a parameter that I've already created with a couple wood materials that I want to be able to utilize. Now I know that this material is going to, I'm just going to change it to, I'll just say wood material, as I've just said that, because material will give us some problems when we get into the code. So I thought it would be a good idea to actually look into an example of how we can build an iLogic rule from the top downwards to go and do that. Because of course we can do quite simple iLogic rules to change a material and change a appearance. But it's quite nice to be to look into the other side of it, where we actually run through any job and have the ability to change all the materials of each component within it. So if I go and say add rule, we'll call this rule material. And when my iLogic screen appears, now I've gone and created some snippets because it's quite a bit of code to get this right. And it looks like I need to just load them in. Open custom snippets. Sorry, it was there this morning when I had a look, but then I rebooted my machine. So let's go and iLogic. This is a snippet that should do. Right, so there it comes in. So I've got some snippets that I've created already. Now I've got a simple for each rule, which and kudos to Alex Field and my colleague for the tips he gave me yesterday on how to put it into a transaction wrapper. So basically the transaction bit from here, firstly, to describe what we're trying to achieve, all we really need is this line one and the for each statement there. The rest of the transaction stuff is more for the undo functionality, which I'll show you once we've run the rule. So from here, I've got a for each loop that's going to look through every document within my assembly, which is great, except in that I've got some sub-assemblies. So now I need to add an extra layer of filter just to make sure that it's only going to try and change materials on a part document, whereas the assembly document doesn't have a material. It's not relevant because it's driven by all the parts that are placed in that assembly. So this document type, I've just used the code. You could use an enum if you wanted to, but in this case, the code was easier for me. So there we go. We've now got a for each loop that's going to look through every document within this assembly, and we then want to go and make the material change. So there's a snippet for this. I'm going to adapt it a little bit to work with this. If I go to our properties and we go and find the material of component, except I'm not going to use the of component. I'm just going to leave it as our properties.material. And that material that you see there in the brown now is why I couldn't have that parameter named as material, or else it goes blue and thinks that I'm trying to talk about a parameter. And then in here, we're going to just put odoc.displayName. So basically, each time it cycles through one of the parts, that part becomes the odoc. And then we're going to use the display name of that file, because it's actually a file, not just a part. But in this case, once we've gotten through this filter, it is only a part. And we're going to then change it. And then we need to say what we want to change it to. So we're going to say equals wood material, right? So now we link that to an I property. So if I go ahead and run that, it'll change it to the first of the materials. And you can see some of the appearances. So I'm pulling a bit of smoke and mirrors here, as all of the materials are now whatever I've set them to, but some of the appearances have already been overridden, which is why we still have the glass look on those and the I suppose plywood on the top. So if I go and have a look at my parameter now, I can then go and change it to maple, which isn't the nicest of materials, especially for a cabinet, but nonetheless, there it is. We've got oak, and we can also go to walnut. So of course, the next step would then to be put this parameter onto our form, which I'm not going to worry about because this is actually a live model rather than my template. It should all be done on the original template so that it comes through into all our further designs. But for this example, we'll just leave it here. I like the cherry. It looks pretty good as a cabinet, so we'll leave it on that. So if I go back to my form now, I can then go and start looking into some of my outputs, other than the BOM, which we've already looked at. And just to show you, that BOM was saved. I'll go have a look. There was my original BOM there. And as we start going through, so looking at my main assembly now, I don't have a drawing currently. So I'm going to go ahead and create an overall drawing. Let it generate, and we can see that we've got a drawing. I've opted not to have any dimensions come in at this stage, but I do have a rule that will bring in a parts list for us. So there's my parts list, and once again, with all my cutting list attributes added or properties pulled through. So I've already got a parts list with the cutting list of all the panels and all the rest. And of course, we could then just simply go and add an auto balloon, choose my view, choose all my components, and then we just need a place. So I'll just go with a vertical on the side here and place it. And of course, there we're already moving along nicely. There's some of the components can't be seen, which is why we don't have all the numbers. I would probably need a few more views, but that's okay. And then of course, we could dimension here as well as per normal. So that would be, I suppose, an example of where automation sort of gets you to a point, and then designers need to then go and add in the extra factors, be it dimensions, a bit of an auto balloon, or populating certain things, maybe some more views if necessary. And I'll give that a save and leave it as is. And then another side of these configurators, because once again, it's quite easy to get a model to this point, but there might be some factors that come into play that you can't always control, i.e. a customer might be wanting the backboard to be pre-cut for them so that they could have their cables running through and potentially pipes and hoses coming from the filter, or perhaps from your air pump going to your air stones, or whatever the case is, right? And there's always going to be those kind of live customizations to models. It's kind of impossible to cater for every scenario, especially if you're in a more bespoke environment. So to show you that this workflow can work for these sort of things, I'm going to go ahead and do a custom modification here. So I'm going to go part priority there and just select this backboard and go ahead and open it. So you'll see that I've already got some 3D annotations placed on it, as it's just a base panel, and it's quite easy to place those annotations so that they come into the drawings right away for our default sort of cutting list. And I want to go and make some modifications to this board. I just want to make sure that I've got this orientation right. We'll do it, it'll come out the way it does. So I want to make a cut in the top corner. Head and do project geometry to keep it simple. I normally don't condone the use of project geometry, but in this case, it's all right because our configurator has already done its bit. We'll put a 200 square cut in there, and we'll put a 150 hole cut in here. And we'll just go ahead and dimension it from the edges. So if I go back to 200, space it off from the top by 200, from the bottom by 200, and that's good. Right, so we'll just do a normal cut. So normal Inventor processes here, we'll do a cut through all. Great. Now I want to ensure that when this drawing gets automatically created, that those dimensions come through. So I'll just place some quick 3D annotations. And of course, this is now optional to the designer. In the case of a once-off, this is just a bespoke cut that the client requested. I don't necessarily have to do this as 3D annotations, but I'm just going to run with it quickly to show you that the dimensions will just pull through like all the other dimensions. As long as you're placing them on the planes that you plan to create your views with, it'll work out fine. So I'll place just those. We want a diameter on our hole too. Right, great. Give that a save. Jump on back to my assembly. Give it a save. So we've got a nice hole for our cables. You can see my filters changed to the wood as well, which technically shouldn't have been right, but we could have put in part names as a filter as well, other than just parts. Nonetheless, we can bring our cables through the bottom, which gives us the loop, and our hoses can go through the top. Very nice. So when it comes to the rest of the automation that I've got, I can go create component drawings. Now this is, I'm going to start it because I'm going to talk a little while, and it's going to create a drawing for each component. Once again, I haven't put any specific filters on, so you'll see some of them will actually be the sub-assembly. So we'll get a drawing here of the sub-assembly of the lid and of the sub-assembly of the cabinet, and then we'll have all the individual panels. And I appreciate that, some of the paper space has been wasted and we only have one panel per sheet, but it is an example rule. Like I showed you with the material rule, we can obviously add more filters to have certain things, I suppose 2 panels per drawing, or based on the height of those panels, we could go and split them into different categories, or put multiple panels on a sheet. So as it goes through, I know that the back panel is going to be the last drawing, so we're just waiting for that one really. You can see all the other dimensions are coming through automatically, and that's once again based on those 3D annotations that I've placed for each panel. There's one of the door panels. I think all the doors are individual, so we'll have to go through 3 of those. There's another one. I think we're getting close to the back panel, so look out for it. There we go. There's our back panel with the new dimensions, and that was the last one. So just to go and review that, I'll just quickly go back into this part. And if we go have a look here, we can see that if we open the drawing, you can see that the drawings come through with the dimensions, and they're all already spaced out and placed. Now, of course, there's nothing wrong with going and placing the dimensions at this point. So if you don't like the whole 3D annotation placement style, you could just, leave those dimensions out and come and place them when you get to this stage. The difference is that, with having done it as a 3D annotation, I can regenerate those drawings as much as I like, and those dimensions will always appear. Whereas if I didn't, I'd have to be careful about regenerating my drawings. And just to show you that in each category now, if I go look at the parts, each part is now accompanied with its own drawing, which has been saved. Assemblies all have their own drawings. If I go to the lid folder, same story. We've got drawings for each part, and we've got drawings there. So they've all been saved and populated. We could have had PDFs output in if we were confident enough to have that final drawing already output from the start. Our output options are, I suppose, endless. We could have a step rule to output a step model, a BIM file format or accepted file format, published with all of the properties from here. It's entirely up to you. Other options that we could be looking at would be to have it driven from Vault. So when we start making use of the more advanced job processes, like PDM Booster or Cool Orange, we can then have an iLogic rule triggered. So from basically perhaps a spreadsheet or an Excel document or an XML comma delimited format or whatever it is, we could have those parameters set up as from a sales or customer facing document, have those dimensions already in our Vault, and then just have the Vault populate the model with all the drawings from the get-go, and then we as designers just go and review those. The options are limitless, I guess. And just remembering that from what you've seen here, you might not think that a full configurator is the solution for you. You want to do the whole end-to-end solution, but you might have seen some key things that could help you, like, we're always creating design documentation drawings for every part that we do. It would be nice to just click a button and have all those parts done on any assembly that I potentially build, and then I can just go and tweak those drawings as I would have anyway. It's little things like that that can save you time, and I guess that's where the automation message needs to come through, is that we want to help with any process. It's not that we want to come and do a full end-to-end configurator for everyone. We know that doesn't fit everyone. If you're in a more bespoke environment, there might be certain tasks, creating bombs, creating DXFs, as Simon mentioned, those sort of tasks that can certainly be automated and help without necessarily going through the process of building a full-blown configurator. So yeah, that's all from me. So I'm going to hand back to Simon. And thank you very much.
Thank you, Chris. Awesome. Really great presentation, as always. I know that, sorry, wrong camera. Just getting used to this new environment. There's a couple of questions that came in, Chris, while you were doing the presentation. And one of the things that I was really fascinated by, and I always am when you show it, and I know you don't think it's very much, but actually, having worked with many customers over the years, I know it's a massive thing, is that ability to automatically create drawings and have them, you just press a button and it goes off and it takes the whole assembly and automatically does that view and that view, and sort of does them all and saves them in a certain file. Now, there was a question, and I thought it'd be worth just jumping in now and just asking the question as to whether you can automate the drawing board a population. Obviously, it came up, and I think one of them said backplane or something. It sort of had the naming, but whether you can automate some of the population of other elements of that, I don't know if you can answer
certainly. So it's all based on our properties when it comes to your title block, and as I'm passing a part over, that part is referenced in that drawing, so we could just simply reference the our properties. So yes, your full title block population, all the fields within your title block can be automatically populated from your original model. So that original form could have had those details in, or even in my very first form that you saw, that project name and that project number that I put in, or part number or client number, or whatever it was that I wanted to put in there, that could all filter through right into your drawing borders. So yes, you can indeed populate those fields with it.
Great. Okay, Chris, thank you. There was another question, but I'm going to answer it in my presentation now, because I'm just going to wrap up, because the question was more around what is the process, because one of the things that I'm always fascinated by with regards to on camera, thank you, with regards to automation projects is quite often we'll talk to a client, and a lot of clients sort of come up with the phrase that everything we do is bespoke. Everything is bespoke. Everything is a one-off. Now, yes, that may be true. But one of the things I'm always interested in is, well, okay, take a step back. Is 80% of it based on the same parameters? What Chris showed there was the designing of that fish tank, and it built the right thing, but maybe there's a few tweaks on the top that you just need to manipulate manually on top. Well, doesn't that make the process quicker? If you're talking about a week-long, day-long, however long your design process, if you could do 80% of it at a click of a button like Chris did, doesn't that make the whole design process easier? Yes, you may not be able to do everything, because there is that one annoying customer that is always going to say, hey, can you do that, but can you make it blue, or whatever it may be. But if you can for me, automation is not about having the car configurator where that's all you're allowed to buy. You can't go to BMW and say, actually, I want I don't know if they do a pink car. You can't just create something specifically out for you. But maybe you could do 80% of it and then do a paint job on the top, and that's kind of the idea. And if that makes your life as a designer or a salesperson out there on the road selling your products easier, then that's the whole purpose of automation. And like I said, automation takes a few things. Now, what we always do, now this is our process on the screen here, is we have a process of how we've delivered many of these sorts of projects for customers. And there are some customers where they will simply want us to do the whole thing. So they've just got their salespeople or their designers pressing a few buttons, like you see with Chris. There are some customers that want to understand, how the code is written and have the ability to edit and tweak that code in the future. So whatever your preference, we're here to help you deliver the project and achieve your project goals. But we always kind of take a phased approach to any of these projects, whether that's understanding what your needs. We normally do a proof of concept. We always have to do a scope of works, and that's simply where someone like Chris will fully understand what your products are, how your products work, and where you want to get to, and what the rules are behind, and what the outputs are. So sort of defining the whole project. And at that point, we then detail a phased delivery plan that's fully project managed from start to finish, and then we deliver the project over the course of the next however long it's going to take. You're fully involved in any sort of automation projects that we deliver. Your technical staff are involved, testing, making sure that it's doing the right things. And Chris has done many of these projects for us, and we have a lot of happy customers that are now a lot more efficient, a lot able to deliver their projects to their customers a lot quicker and more effectively. So that's kind of how we do it. If you're, of course, interested in any of this, if you'd like to talk to any of the team, you can always drop me a line. I'm the sales manager for the manufacturing division. We have a team of sales and technical consultants that are able to advise you about the best approach as to whether it's even an option for you. Of course, please do not forget to follow us on, not that one, sorry, I need to press this screen. Follow us on all of our social media channels, LinkedIn, Facebook. Please also don't forget to like this video, to go ahead and subscribe to our YouTube channel if you're watching it on YouTube. And I would really look forward to seeing you on our next webinar. I'm going to end this webinar now, but thank you, Chris. Thank you all for watching, and we'll see you on the next one.